In this video, I will explain electrical resistance. Resistance is the opposition to the flow of current, where current is the movement of charge. In a metallic conductor, moving charges are electrons. Consider this model, where the electrons are represented by marbles, which flow along the length of a wire, demonstrated by jenga blocks. Energy is provided by elevating the table, which attempts to simulate a voltage source such as a battery. When energy is supplied, the electrons flow through the wire. This demonstrates current. It took about 6 seconds for some number of electrons to pass a point. This is an arbitrary value of time, but is representative of how much current is flowing, since current is how many electrons pass a point in a certain time. A longer time means a smaller current. Therefore, any resistance to the flow of electrons will decrease the current, demonstrated by an increase in time. The next thing to consider then is what determines the amount of resistance. It can be determined experimentally that resistance is equal to the resistivity times the length, all divided by the area of the material. Resistivity is a material-specific value. So according to this equation, increasing either resistivity or the length will increase the resistance, whereas increasing the cross-sectional area will decrease the resistance. Let's test this. We've increased the wire's resistivity by adding in obstructions, just like the material's lattice structure. The electrons collide with these obstructions, impeding their flow. This time, they took 11 seconds to pass through the wire. We've decreased the current while increasing resistance. Now, let's increase the area of the wire. This only took 3 seconds. The electrons have more space to flow through. Increasing the length of the wire simply means the electrons will collide with more obstructions. You can see here that the electrons at the back had to pass by 2 obstructions to reach the end, whereas the electrons at the front flowed through unobstructed. A resistor can be considered as a wire with a known amount of resistance. Here we have reduced the width of the wire in one spot, representing the presence of the resistor. The electrons once again took 11 seconds, and you can see where flow is restricted, at the location of the resistor.